We will learning to you about the retaining walls in a few separate videos. First, we will learn about general types of retaining walls, components, types of failures in a retaining wall, general forces and behavior of retaining walls, design of cantilever retaining walls, and lastly, typical reinforcement in a cantilever retaining wall. What is a retaining wall? Retaining walls are structures used to provide stability for earth or other materials at their natural slopes. In general, they are used to hold back or support soil banks and water, or to maintain difference in the elevation of the ground surface on each of wall sides. Elements of retaining walls. Each retaining wall, divided into 3 parts, stem, heel, and toe and heel slab, make up for the foundation of the wall. Some walls have a key provided in footing to prevent it from sliding. Stem. Stem is the wall itself. The face of the wall is either the exposed portion, front face, or the portion against which the backfill rests, back face. Toe is the portion of the base slab which extends beyond the front face of the wall. Heel. Heel is that portion of the base slab which extends away from the back face of the wall. Toe and heel are also used to denote the extreme forward and rear parts of the base slab, respectively. Shear key. Key is provided in footing to prevent it from sliding retaining walls. The stem may be provided with drain holes with slope for the water drainage. Similar sloping perforated pipe may be provided below the same for water drainage. The soil behind the stem can be coarse aggregates so that water percolates and exits via drains. Sometimes the portion of wall in contact with the soil is usually provided with some kind of waterproofing. Types of retaining walls. 1. Gravity wall. Type of a retaining wall depends on its use. Gravity walls, generally, are trapezoidal in shape, but also may be built with broken backs. The base and other dimensions should be such that the resultant falls within the middle 1/3 of the base. Gravity wall which retains soil by its own weight. Gravity wall is of a bigger size and usually built by stone masonry and rarely in plain concrete. The top width of the stem should be not less than 30 centimeters. Because of the massive proportions and resulting low concrete stresses, low-strength concrete can generally be used for the wall construction. Also, the height of gravity walls not less than 5.0 m in height. Two, cantilever walls. They are the most common type used as retaining walls. A cantilever retaining wall is one that consists of a wall which is connected to foundation. A cantilevered wall holds back a significant amount of soil, so it must be well engineered. It consists of a vertical wall, heel slab and toe slab, which act as cantilever beams. It is generally used when the height of wall is up to 6 m. The cantilever retaining wall are of 3 types. 1. T-shaped. 2. L-shaped. 3. T-shaped with shear key. vertical stem and cantilever retaining wall resists earth pressure from backfill side and bends like a cantilever. The thickness of cantilever slab is larger at the base of stem, and it decreases gradually upwards due to reduction of soil pressure with decrease in depth. The heel slab acts as a horizontal cantilever under the combined action of the weight of the retaining earth from the top and the soil pressure acting from the soffit. The toe slab also acts as a cantilever under the action of the soil pressure acting upward. 3. Counterfort wall. Counterfort walls are cantilever walls strengthened with counterforts monolithic with the back of the wall slab and base slab. The counterforts act as tension stiffeners and connect the wall slab and the base to reduce the bending and shearing stresses. To reduce the bending moments in vertical walls of great height, counterforts are used, spaced at distances from each other equal to or slightly larger than 1/2 of the height. Counterforts are used for high walls with heights greater than 8 to 12 m. 4. Buttress. When the triangular beams are placed on the front side of the retaining wall, instead of on the backfill side under certain situations, the retaining wall is known as buttressed retaining wall, and the triangular beams are known as buttresses, instead of counterforts. The structural action of the stem is the same as in a counterfort retaining wall. 5. Bridge abutment. A wall-type bridge abutment is similar to a cantilever-type retaining wall. In this, the top of stem of the retaining wall is braced by the deck slab of the bridge. The stem can be designed as fixed at the base and simply supported at the top. 6. Box culvert. A box culvert acts as a closed frame. It consists of single or multiple cells. In addition to the lateral earth pressure, a box culvert also resists the vertical load from the soil above it and is also resistant to the vehicle loads.